All right, so in number 10, they give us f of x, and they want us to find the inverse. Now remember, whenever you want to find the inverse, we want to switch the x and the y. So see this x right here after the 12, we're going to make that a y. And isn't this just like a fancy way of saying y? So we're going to change this y to an x. Okay, so there you have it. So the y becomes an x, and the x becomes a y. And now all we have to do is get this y all by itself. All right, so let's first add 4 to both sides of the equation. Which will leave us with x plus 4 on the left-hand side and just a 12y on the right-hand side. And then to get rid of the 12 in front of the y, let's just divide both sides by 12. All right, so now instead of y, I'm going to replace this with f inverse of x. Okay, so now let's look at the answer choices and let's see what they want us to do with this. So if they want us to divide anything, well, x over 12, but that would be plus 1/3, not plus 4. Okay, look at choice 3. It says the exact same thing. We don't even have to manipulate that at all. So we're just going to leave that as x plus 4 over 12. So choice 3 is our answer. All right, now the next one, number 11, they're asking us to do the same thing, right? They want us to find the inverse. So we're going to start it the same way. We're going to change this y to an x. And we're going to change this x to a y. Okay, now we know we have to get this y by itself. So let's, again, just get rid of this number that's hanging out here by itself. This time we have to subtract it. So that's going to leave us with x minus 1/2 equals negative 6y. All right, now in the last example, we divided by the number in front of the y. Right, we just divided both sides by 12. So you could do that here. You could also, if you want, let me just move this up. You could also divide both sides by negative 6. But then you're going to have a fraction divided by a whole number, which is fine. You could definitely do that. But I find when we're dealing with fractions, rather than dividing, personally, I feel like it's easier just to multiply both sides by the reciprocal. So the reciprocal of negative 6 over 1 would be negative 1 over 6. So I'm going to multiply both sides by negative 1/6. And the reason I do that is because a negative 6 over 1 and a negative 1 over 6, anything times its reciprocal, cancels. So that's going to leave us with just y, which we could replace with f inverse of x. And then just distribute. You get negative 1/6 times x, which is negative 1/6x, and negative 1/6 times negative 1/2 would be positive 1 over 12. So that is choice 3. All right, number 12, a survey about television viewing preferences was given to randomly selected freshmen and seniors at Fairport High School. The results are shown in the table below. Okay, now what I'm noticing is, first of all, they don't total everything out. So let's go ahead and do that. Okay, now the first part says a student response is selected at random from the results. State the exact probability, so what that means is don't round, that the student response is from a freshman given the student prefers to watch reality shows. Okay, so we're looking for the probability of freshmen given reality. Now remember, if we're given reality, we want to just look at that given category, which is this given column. So really all we're doing is we're only looking at the numbers in this column right here. These are the only numbers that could make our answer. Okay, this is given reality. So the total number of people that watch reality, since we're given reality, is 213. So that's going to be our denominator. Now, out of those 213 people, how many of them are freshmen? Well, let's see. 103. All right, so this is the answer to the first part. Now, the second part wants us to determine whether or not the events prefers a reality show and is a senior or independent. All right, well, if the two events are independent, then it means it's going to fit this formula. The probability of reality and senior will equal the probability of reality times the probability of senior. Now, I'm going to put a question mark here because we don't know if this is going to be true or not. All right, so let's start with this, the probability of reality and senior. All right, so this right here, there's 110, right, students who prefer reality and are seniors. So 110, and it's going to be out of the total. Unless we're given a specific category like we were up here, the total number will always be our denominator. All right, so we said that was 110 out of the total 536. Okay, so now over here, the probability of preferring reality, well, the total number of people that prefer reality is 213 out of the 536 people. And then we want to multiply that by the probability of being a senior. So altogether, let's see, we have 260 seniors out of the 536 students altogether. All right, so now we just want to know if these two sides of the equation are equal. So you can plug them in your calculator, you could write them as fractions in simplest form, you could write them in decimals, however you want, just as long as you could tell whether or not the left side equals the right side. Okay, so if we plug this in our calculator, although that does simplify, if you want to write it as a decimal, that would be approximately 0.2052. Okay, let me bring down the equal sign. We may have to put a slash through that. Okay, and then if we determine what this side is equal to, it's close, but it has to be exactly the same. It's not. It's approximately 0.1928. So these are not equal. So what we could say is no, the events are not independent. All right, so there we have it. Now the next one is very similar. Okay, so this one's about a public radio station holding a fundraiser. It summarizes the donor category and method of donation. All right, so we could see again, they do not total anything up, so let's do so. All right, so there's two things they ask us. It says to the nearest thousandth, find the probability that a randomly selected donor was categorized as a supporter, and then given the donation was made online. So we're looking for the probability of being a supporter given online. All right, so I'm going to make my little fraction bar since it says probability. Now, if we're given online, okay, we're given online. Here's online. This is our given category. So if you want to highlight that row, you can. This right here is the only numbers we're going to be using. So the total number of people who made online donations was right here, 3,216. So that has to be our denominator. Now, out of those 3,216 people, we want to know how many of them are supporters. So out of these people, 1,200 of them are supporters. Okay, now I just want to point out, I probably should have emphasized this earlier, but they want us to round to the nearest thousandth. So although normally you would leave it exact as a fraction, or you could rewrite this in simplest form, this time they want us to plug it in our calculator and round that to the nearest thousandth. So the nearest thousandth, I am getting approximately 0.373. Okay, so now the next part, it says, do these data indicate that being a supporter is independent of donating online? All right, let me change colors here so it doesn't blend in. We know that if they're independent, the probability of being a supporter and donating online would be equal to the probability of being a supporter times the probability of donating online. So let's put a question mark because we don't know if this is true. All right, so let's look here. So now the probability of being a supporter and donating online. So here's supporter and here's online. If we meet in the middle, there's 1,200 people altogether out of the 4,288 total. Remember, if you're not given a particular category, that's when you use the total as your denominator. You're looking at everyone. Right, so we said that was 1,200 over 4,288. All right, so now the probability of being a supporter, well, altogether there are 1,600 supporters out of the the 4,288 total people. So 1,600 out of the total. And then the probability of donating online is 3,216 out of the total. All right, so now what we have to do is we have to figure out, does the left-hand side of this equation equal the right-hand side of the equation? All right, so if you plug this in your calculator, you could rewrite it as a fraction or a decimal. If you rewrite it as a fraction, it's 75 over 268, which if you left it as a decimal, that would have been approximately 0.2799. Okay, we want to know, is that equal to? And then if you multiply these, actually, look at that. It gives you the same exact thing. So they are equal. Okay, I'm going to put a little check mark. If you want to write this decimal again, you can. All right, so these are equal. So if they are equal, what it means is yes, they are independent of each other. So let's just write that out. All right, so yes, and I'm literally just restating this question, okay? The data indicates that being a supporter is independent of donating online. All right, so I'm not sure if you've read number 14 yet, but they tell us the number of students in the school, the number of students who participate in sports, the number of students who participate in music, and then they give us the probability that a student participates in sports or music. All right, and they want us to find the and. Okay, that's what we're looking for. So you want to find the probability a student participates in both sports and music. All right, well, you could do this either through a Venn diagram or through the formula. So if we did this through a Venn diagram, let's see, we have, this will be sports, this will be music. We know this is the total number of students in the school. 649 total students play sports. 433 total students are in music. And then the or. Remember, these three circle numbers would make up the or. So the or, right, these three circle numbers right here would have to add up to 974. Okay, so here's the deal. Basically, this plus this plus this is supposed to equal 974. Now, we don't know any of the numbers within the circle. But think about it. If you know these two numbers on top, if we were to add these two numbers, shouldn't it add up to more than 974? Because whatever number is in the and spot in the middle is accounted for within the 649 as well as within the 433. So if we add these two numbers up, let's figure out how far above 974 they are, and that'll tell you which number was accounted for twice. All right, so if we want to figure out how far above it, let's just subtract 974 from it. All right, so let's do this. So we get 108. All right, so what that means is this is the number that was accounted for twice. That's our and. I don't know if I could fit that in there. Let's see, 108. Okay, now, they want to know what is the probability that a student participates in both sports and music. So probability we know is a fraction. So there are a total of 108 who are in both over the 1,376 students altogether. All right, the other way you could have done this is you could have just used the formula, right? They give us the or. We know the probability that a student participates in sports is 649 over the total. And then we know the probability of music is 433 over the total. And then this is what we are solving for. You know, it's actually easier if you want to solve this equation to just get rid of these denominators here, and just make sure that when you write your final answer, you put it over the total, right? So if we were to solve this equation, I'm just going to combine my like terms. So these right here combine to give us 1,082. I'll bring down the minus x. And then if I subtract 1,082 from both sides of the equation, I know I'm writing on the next problem. Let me just move this up a little. This is going to give me negative 108 equals negative x. So basically, when you divide both sides by -1, we will wind up with positive 108 equals positive x. Okay, so this is the and because we're looking for the probability, right, don't forget to put it over the total. So you get the same answer. Okay, so it looks like number 15 you could either do through a Venn diagram or the formula either. It does not matter either way. I'll show both ways. Okay, so we could do it. Let me just separate these. Okay, so you could either do it through a Venn diagram or through the formula. Now, they told us the probability a student prefers math is 1/4, so I put that on top of the math circle. The probability that a student is a junior is 1/16 over 459. And the probability of the or, right, that they're a junior or chooses math is 47 over 108. So we know the or means the sum of these three circle numbers. Now, if you were doing it like this, through a Venn diagram, we know, same exact way as the last one actually, we know that if we were to add up the two numbers on top of the circles, it'll add up to more than this total because this only includes the three circle numbers. If you were to add these, whatever number is in the center here is accounted for within the 1/4 as well as within the 1/16 over 459. So if we were to add the two numbers on top, let me just do that down here. What we would have to do is, from that answer, right, if that answer is going to be more than this, we would subtract this from it to figure out what number was accounted for twice. So if we subtract 47 over 108 from that, that'll tell us what number goes here, right? What's the probability of math and junior? Okay, so if you figure out what this is all equal to, you wind up getting 31 over 459. So that is the value that was accounted for twice. So basically, that's our and. So this is the probability of preferring math and being a junior. So that's the answer to the first part of the question, right? That they wanted us to find that probability. Now, if you had done it through the formula, it's technically the same thing, right? We're going to plug in the or. We're going to plug in the probability of math. And please do not write these as decimals because although 1/4 is 0.25, this you'd have to round. And then the probability of being a junior, right, the 1/16 over 459, you would have to round as well, and we do not want to round. We want to keep it exact. All right, so to solve this equation, what we do first is we combine our like terms. And isn't that the first thing we did here? We added these together. All right, so when you do, you wind up getting 923 over 1,836. Okay, now the next thing we're going to do is we are going to subtract this over. So when we subtract this fraction from both sides of the equation, all right, we wind up with negative 31 over 459 equals negative x. And then basically when you divide by -1, you wind up with positive 31 over 459. Okay, we're not done though because they also want us to determine are the events, the student is a junior, and the student's favorite subject is math, are they independent of each other? Okay, so if you recall, this right here is our formula for independence. Now I put a question mark because we don't know if this is going to check out or not. Now on the left side of the equation, isn't that what we just found? We just found the probability of math and junior to be 31 over 459. Okay, now we want to know, is that equal to? Well, we know the probability of math is 1/4, and they gave us the probability of junior is 1/16 over 459. Okay, so let me bring down the left-hand side of the equation. And on the right-hand side, you have to multiply those together, and when you do, we do not get 31 over 459. It's close, like very close, but it has to be exact. We get 29 over 459. So we could say no, the events are not independent. And this work right here backs up our answer. Okay, so they want to know which of these equations represents a parabola with a focus of -2, 5 and a directrix of y equals 9. All right, so let's just, I like to graph this out. So let's see, we have a focus of -2, 5. So that's our focus. And we have a directrix at y equals 9. So it's going to look like this. Okay, so this is our directrix, and this is our focus. All right, now we know the way a parabola works, right, is the vertex is midway between this point and this line. So if this is at a height of 5 and this is at a height of 9, is it midway between 5 and 9? 7. So it would be at -2, 7. You could also say, all right, let's count our way up. 1, 2, 3, 4. Half of 4 is 2. So if I were to go up 2 from here or down 2 from here, I can meet right in the middle. Okay, so this is our vertex, and the coordinates of that are -2, +7. All right, now we have to decide, does our parabola open up or down? If the directrix is on top, it's never going to open up into the directrix, right? It's never going to touch that directrix. So it always opens away from the directrix, right? It engulfs this focus. So our parabola is going to open down. All right, so this right here is a setup of a parabola that opens down. And this, at this point in the year, I think we all have this memorized. So I'm going to write y equals -1 over 4 times. Now, P is the distance from the directrix to the vertex, so 1, 2. Or the distance from the vertex to the focus. So again, 1, 2. So it's 2 units. So for P, I'm going to replace that with a 2. All right, and then it's x minus. Now the h and the k we get from our vertex. So our h is -2 and our k is 7. So we can just plug them right in. So we have x minus -2. Well, instead of having a minus negative, doesn't that become a plus 2? And then in place of the k, we're going to put the 7. All right, so let me just write this a little neater. So we have y equals -1 over 4 times 2 is 8 times x plus 2 squared plus 7. Now, a lot of times they'll have this equation here, but if you notice, they don't. Right? It looks like what they did was they tried to get the term, the parenthesis with the square on it, by itself. Now, we could see our parenthesis has an x plus 2 in it. Oh, by the way, this is a 7. I guess I didn't write up. Our parenthesis has an x plus 2 in it being squared. So we know it's got to be either choice 3 or 4, right? We don't have an x minus 7 being squared, so those are out. All right, so what we want to do is we want to get this by itself. Now, some of you are going to say the only difference between these two equations is this is a positive 8 and this is a negative 8, and don't we have a negative in our equation? So it's got to be choice 4. But let me just show how to get there. All right, so first thing I'm going to do is I'm going to subtract this 7 from both sides of the equation, right? That number that's just hanging out by itself. And then I'll bring everything else down. And we're trying to get this x plus 2 squared by itself. So to get rid of this fraction in the front, let's multiply by the reciprocal. So the reciprocal of -1 over 8 would be -8 8 over 1. Which, I mean, honestly, is just -8. So we could just multiply this side by -8. All right, so these reciprocals are going to cancel off, leaving us with just the x plus 2 squared. And on this side, I'm not even going to distribute because in the answer choice, they don't. They leave the -8 on the outside. So we could see that matches up with choice 4. All right, number 18. So what do we have here? In the quadratic formula, b squared minus 4ac is called the discriminant. Now think about the quadratic formula. Isn't the b squared minus 4ac what's under the radical, right? And we know that if we have a negative under the radical, it's going to create, look, I'm seeing this down here, imaginary solutions. Whereas if we have a positive under the radical, it's going to create real solutions. Okay, so they're saying f of x has a discriminant value of 8. So that's a positive number under the radical. Okay, so that's going to give us real roots. Whereas g of x has a discriminant of -16. If that's a negative under the radical, that's going to create imaginary roots. So g of x is going to create imaginary roots, whereas f of x is not. So see down here when it says which quadratic functions have imaginary roots, we know g of x has to be in our answer. So it's got to be choice 1 or 2, okay, not f of x. Let's cross those off. Now we're deciding between h of x and j of x. Well, here's h of x, and here's j of x. Okay, remember, imaginary roots do not intersect the x-axis. So if you have a quadratic, right, a second-degree equation, this one has 2 real roots because real roots intersect the x-axis. This one is not, see that, intersecting the x-axis. So this one has imaginary roots. So j of x would also have imaginary roots. So this is going to be choice 2. Okay, now number 19. It's also asking which representation of a quadratic has imaginary roots. Now, just looking at this, right, and looking at this picture in choice 3, see this? This is intersecting the x-axis. And it's actually, it has a repetitive root, right? Do you remember that? Okay, first of all, the factor that would correspond with this would be x minus 3. And because it's bouncing off the x-axis, we would put a square on it. But either way, this has a real root of positive 3 because it's intersecting there. So choice 3 is not our answer. Okay, if we think about what choice 1 says, I'm going to actually plot out these points. Okay, so what I did was I plotted these points, right? I went to negative 2.5 and up to positive 2 and put a point. Then I went back to negative 2 and 0 and put a point. So I plotted this. Now we can see this also has real roots because it is intersecting the x-axis. So choice 1 is not our answer either. So basically what we want to do is we want to solve these two equations and see which one gives us a negative under the radical. All right, now I'm looking ahead. I don't know if you could see this without actually solving it. You may be able to just see this kind of in your head. If I subtracted 32 from both sides of the equation, that would leave me with 2x squared equals negative 32. And then I might as well just divide by 2, which leaves me with x squared equals negative 16. Now, when I go to take the square root, look at that. I have a negative under the radical, and isn't that what gives us imaginary solutions, right? So just so I'm going to write my final answer, but x equals, this squared tells us we have two answers, so plus and minus. And remember, the square root of 16 is 4, and the square root of negative is an I. So this is going to be plus and minus 4i. This is the one with the imaginary roots.